today I am going to start your midpoint theorem. My topic is midpoint theorem. Concept of this theorem is the line segment joining the midpoints of any two sides of a triangle. The line segment joining any two sides of a triangle is parallel and equal to half of third side. It can be taken in any two side of triangle. It is not necessarily to take AB and AC. Just like I am taking ABC sides BC and AB. The midpoint joining BC and AC midpoints are like this. Now this line is parallel and half of third side AC. In this way we can take anywhere. Suppose I am taking this two. The joining the midpoints of BC and AC is parallel and equal to half of AB. In this way theorem is applicable for any two side of triangle. Now the theorem is the line joining the midpoints of any two sides of triangle is parallel and equal to half of third side. Parallel and equal to half of third side. That means in theorem it is given D and E are midpoints. Joining D and E, the line segment DE. Line segment DE. Now to prove, what we have to prove? DE parallel to BC. First thing, DE parallel to BC, and second we have to prove DE is equal half of BC. That means half of BC. BC का आधा. Now construction. We will draw CF parallel to BA. CF parallel to BA meets the line DE produced to F. That means in construction BD parallel to CF. BD parallel to CF. Now proof. In this way we can see there are two triangles ADE and CFE. In triangle ADE and triangle ECF. As BD parallel to CF, in construction already I have taken. So angle A, angle BAC, angle BAC is equal angle ECF. Angle ECF because alternate interior angle, due to alternate interior angle. This angle is equal to this angle, alternate interior angle, and this angle is equal to this one because vertically opposite angle. Angle AED is equal angle CEF due to vertically opposite angle. Due to vertically opposite angle. And as we have taken E is midpoint of AC, so AE is equal EC. Now from side angle A SA postulate both triangles are congruent. By ASA, both triangles are congruent. By ASA triangle ADE congruent to triangle ECF. Both triangles are congruent. Now, if both are congruent, so both are congruent, it means AD is equal CF. AD is equal CF by CPCTC, congruent part of congruent triangle congruency, by CPCTC. AD is equal CF. AD is equal CF. And as we have taken P is midpoint of AB, so AD is equal DB is equal CF. AD is equal BD is equal CF, as D is midpoint. Is midpoint, implies we can say DB is equal CF. DB is equal CF. Now already we have taken in construction BD parallel to CF and BD equal to CF. Then according to the definition of parallelogram, a quadrilateral whose one pair opposite sides are parallel and equal is a parallelogram. That's why in this parallelogram, one pair opposite sides are equal and parallel. That's why it is parallelogram. Implies we can say B quadrilateral BCFD is a parallelogram. Is a parallelogram because BD is equal to CF and BD parallel to CF. Is parallel to CF. Now, parallel to CF and as BCFD is parallelogram, so there if one pair of opposite side is parallel and equal, then other side also parallel and equal. That's why DF implies DF is equal to BC and DF is parallel to BC. DF is parallel to BC, implies we can say DF is equal to DE, as E is midpoint of AC and we can say midpoint of DF also, because DE is equal EF by CPCTC. So DE to DE is equal BC. To DE is equal BC and DE parallel to BC, implies DE is equal 1 by 2 BC and DE is parallel to BC. In this way, your theorem is proved. The line segment joining the midpoints of any two sides of a triangle is parallel and is parallel to third side and equal to half of it. That is proved. This theorem is a midpoint theorem. Understood? Okay.